Hi friends, welcome to GMK tutorials. In this video, we are going to see about the segmentation related concepts. So previously, we discussed different types of compression and coding redundancy techniques. So if you have my channel, subscribe so please subscribe our channel for latest videos. Okay, so let us move on to the topic. So generally, image segmentation it is a very crucial operation in the image analysis. If you are done segmentation very effectively, the results are also very superior compared to the normal operations. So the segmentation means that dividing the objects in the corresponding image or maybe constitution of the corresponding parts or maybe objects. So for that purpose, suppose if you want to identify the corresponding objects, borders, edges are very important parameters. At that time, how to identify the edge pixels, how to identify the edge links, and how to identify the line or maybe point or maybe isolated point. That is also very important concept if you want to identify the objects in the corresponding image. So for that purpose, let us move on to the one by one how this is very effectively used in the image processing analysis point of view. So let's move on to the first one. Generally, the segmentation methods are based on the detection in the sharp local changes. That means there is a changes in the intensity values or maybe abrupt changes in the intensity values. Those are the very important points for segmentations also. So in this, the three types of image features in which we are interested for segmentation are like isolated points. Second one is nothing but edge lines and edges, lines and points. These are the three important parameters for image segment. Edge pixels means these pixels are at which intensity of an image or maybe different to the background. Suppose if you are taking the edge line means or maybe any point is there, this point is nothing but edge point because this value is completely different from the background. So if you are treating it as a background pixel is the black, this is nothing but like yellow color. Obviously there is some intensity difference in the background pixel as well as the object pixel. That is generally called as a edge pixel. Suppose the edge link means the line between the corresponding edges is called as a lines. We can also call it as a edge segments also. Okay, that is the basic difference. If you want to identify the edge detectors or local image processing methods also detect the edge pixels. That is a very important. So for that purpose, a line may be viewed as an edge segment. This is nothing but line means that it is an edge segment. That means which combines the two edge points. Okay. So let us move on to the next one. Next one. Generally, in the background, derivatives and so generally, if you want to identify the edges means that there is a short transition, right? So we are using two types of derivatives. One is nothing but first order and second one is nothing but a second order. First order derivatives also following some approximations. That means that it must be zeros in the areas of constant intensity. That means the derivative of first derivatives. For first derivative point of view, first derivative approximation, this value is a constant. This value, first derivative value is a constant at that means this must be 0 at a areas of constant. That means the first derivative value is 0. First point 0 for constant intensity, Second one is nothing but must be non-zero. This value is non-zero. Second point, non-zero abrupt changes in the values. So third point is nothing but for the first derivative, it must be non-zero at a point along an intensity ramp. So it is also non-zero for along the intensity value. Non-zero along intensity value. So this is the first order. For second order derivatives also it follows some three rules. That means there must be zero in the areas of a constant density. First one, this is also first is same for second derivative, same as first derivative. Okay, now. So second one is nothing but must be non-zero at a ramp. So wherever the ramp like structures are there, that value is non-zero. The third case is nothing but must be zero along the intensity ramps. Must be zero along the intensity ramps. So this is the only difference. Must be zero along the ramp intensity. These are the three approximations for first derivative as well as a second derivative. So let us move on to the next one. In case of the derivatives, we are using the first order derivative for a function that can be represented as dou f by dou x value is equal to f dash of x, we can also f dash of x, that is equal to f of x plus 1 minus f of x. So this is the first derivative for a function. At the same time, for second derivative, dou square f by dou x square equal to f double dash of x. So that value is equal to, just here we are taking a two derivatives, that is nothing but f dash of x, nothing but f dash of x plus 1 minus f of x, right? We know that f dash of x is equal to this one, right? Just you have to substitute that one. Therefore, that is equal to f of x plus 1 minus f of x minus f of x. So that gives rise to f dash of, it gives rise to f of x plus 1, f of x plus 1 as well as wait a minute. So f dash of x plus 1 minus f of x. Now f dash of x plus 1 value is equal to so the second derivative directly I can represent the equation, that is nothing but second derivative is nothing but f of x plus 1 minus plus f of x minus 1 minus 2 into f of x. Okay, this is a second order derivative with respect to corresponding function. Just you have, in case of the derivative, just you will take the f of x is a reference value. So next value for one derivative, for the second derivative is also just you will take the previous value. Then you can get the this kind of the approximation. Okay, so this is for dou square f by dou x square point of view. Suppose let us move on to the detecting of the isolated point. So for that purpose, just we will go for the Laplacian parameter. That is nothing but Laplacian parameter can be represented dou square detecting the isolated points. That is nothing but dou square f of x comma y is equal to dou square f by dou x square dou square f by dou y square. So from this approximation already we know that dou square f is already written in the previous example. Now you have to represent the dou square f by dou y square is equal to f of x comma y plus 1 plus f of x comma y minus 1 minus 2 into f of x comma y. So this is the derivative with respect to second order derivative with respect to y. At the same time, for derivative with respect to x is nothing but that is equal to f of x plus 1 is a constant because of is a where x is a constant, x is a variable and y is a constant. Therefore, f of previous value that is nothing x minus 1 comma y minus 2 into f of xy. This is the first or second order derivative with respect to x and y. Now, if you are adding those two equations, it becomes a final equation. That means, if you are adding this one, just you will get. So this is, let it be considered equation number 1. Equation by adding equation number 1 and 2, you will get a dou square f of x comma y. Finally, we can get 1, 2, 3, 4 overall. 3, 4, 5 values are there. Okay, 1, 2, 3. These are the so 5 values you will get. So based on those 5 values, you can represent one kind of a matrix that is similar to, by adding of those values, we can get matrix structure like this. So the coefficients of the previous values can be represented as, so where 1, 1, 1, 1, minus 8, 1, 1, 1, 1. These are the values for the corresponding pixels if you are taking the diagonal elements. If you are not taking the diagonal elements, there should be a different criteria. So that can be represented in the another version. So 3.37. So let it be see here. Just you will get a 4 values in this case. So if you are taking the diagonal elements as well. Otherwise, the filter is like this. If you are not taking the diagonal element into the consideration, you will get a values of this is a 1, 1, 1, 1, minus 4. Sorry, this value is 0. This value is 0. This value is 0. 0. Wait. So the values are, so let it be see here one by one, where f of x comma is a minus f of x comma. So this is a central value. This coefficient value is equal to minus 4. This central coefficient, and f of x plus 1 comma y, f of x plus 1. So the central coefficient value is equal, by adding those two, you can get 4, right? So you will get a value of 4. So therefore this coefficient is equal to minus 4. And the f of x plus 1 comma y value coefficient is equal, this coefficient is also 1, 1, 1, 1. These are the coefficients, all values are 4. So some pixels also not present here. So that coefficient value can be replaced with the 0. Then you can get f of x plus 1 comma y. So this is a scenario where you will get value of 1 in this case, and f of x minus 1 comma y, this is also top one, f of x comma y plus 1 incremented, f of x comma y minus 1, this one. So in this case the diagonal elements are 0. If you are considering the diagonal elements are 0, like if you are taking the diagonal consideration, it is a filter for Laplacian filter. Okay, this is the way you are going to find out the isolated points in the image. So in other words, by obtaining the same information, like, okay, let us say various line detection mask is also available with Laplace filter. Let us see one by one. This is a one filter. These are the two values, minus 1, minus 1, minus 1. So this is a horizontal filter, horizontal line detection. This is for plus 45 degrees version. So in this case, diagonal elements are different. So 2, 2, 2, and the remaining values are obviously less than that of the corresponding values. Therefore, it detects a plus 45 degrees of the lines. So as well as this is also a filter having a minus 1, minus 1. So 2, 2, minus 1, minus 1. So this is for vertical line detection. At the same time for minus 45 degrees, So minus 41 2 2 2 minus 1 minus 1 minus 1. So this is for detecting the minus 45 degrees in the corresponding images. So with the help of these filters, we can identify the lines in the horizontal direction as well as the vertical direction, and plus 45 degrees and minus 45 degrees. So this is a brief introduction about the isolated points, detection of the isolated points, lines, and edges. Just a brief introduction. Just means if you want to identify the corresponding edges, it is a very important for the edge detection point of view. Just how we are going to identify the edges. Okay. Then so just next in the next video we'll see about the how to identify the edges in the images. Okay. So thank you for watching GMK tutorial.